Hello and welcome to another DDMT tutorial. Today we're going to be talking about Behaviour Builder, a really cool feature in the software where we can try and define or quantify behaviours based on semi-consistent patterns within the data. Today we're going to talk about three different methods. The first one is a very simple way of defining the behaviours using marked events. The second is getting a bit more complicated with differential channels. And then the third is where you get very in-depth and detailed using some sort of time series based behavior builder. But all three kind of lead into one another, and that will make more sense as we go on. So to get stuck straight in, there is one thing I need to go over. Within DDMT, you can import in ethogram or focal behavioral data in the form of bookmarks. And this needs to be in a CSV format. And I've got an example here. It needs to be in a very specific format and layout. The first 15 lines is a list of behaviors with the corresponding code and defining what color they're going to be. Now, all 14 behaviors must be filled out, but as you can see, like I've done here, they don't all have to be allocated an actual behavior. So I've just filled out the behaviors I don't have with NA, but you always must have 14. You leave a line blank, and then we come into the time observed behaviors. So these are actual behaviors I observed on the field. And then we have a date, a start time, and then a duration. Then finally the code, which corresponds to the behavioral list above. For example, this was a salt lick. The goat here licked the salt for about 60 seconds approximately. So this duration is in seconds. And that code relates to the behavior. And you repeat this for all your observations. It's worth noting, it does not accept any behaviors less than a second. These need to be whole numbers. Also, if your behaviors overlap for whatever reason, it will try to plot the bookmark in white rather than using the color format you've detailed above. So I've loaded up my goat data into DDMT. I've loaded in my TDO because the time offset is important, because it's going to relate to time to actually be able to bookmark out your ethogram or observation data. So let's load in the observation data. We go bookmarks, and we go to the bottom drop-down menu here, and we're going to select load bookmarks in either the BMK format or the CSV format. We're using the CSV format. So we select that from the drop down, and then we click do action. It will open up a window for you to go and find that observation data. So let's have a look. I think I've put it in here. Right now I can't view it, and that's because it's looking for file types BMK. But if I just change that with the drop down, I can find my goat behaviors here. Select it, click open, and it should load in the behaviors. So it's informed me that 21 behavioral identities have been loaded in, and 0 have not been accounted for. In other words, there's no errors. All the behaviors have been loaded in. I had it in the right format. Looks good. Click OK. So we can go find those behaviors. Use the split navigation. Now, I think I have quite a few behaviors on the 23rd. We've loaded up the appropriate split, and this is the full split in the window, and as you can see, the bookmarks are really clear. as the bookmark coloured lines run all the way down, or nearly all the way down the split. And we can zoom in on this. So they start where I define them to start, and then the bookmark lasts the amount of duration I've specified. Also, it's worth noting, each bookmark has a clear label associated with it. So the green is grazing, the blue is walking, and the red is standing or inactive, maybe even resting. And then I have some other funky colours for some of the other assorted behaviours. For example, this one is flinch. If we zoom in on that, we want to begin to find details within this behaviour or bookmarked area that separate them from the others. The first approach I'm going to use is this really simple marked events approach. And the channel I'm going to focus on is VEDBA, or activity or even energy expenditure. VEDBA is below, and what I want to use is VEDBA smooth. This opens up a good time to talk about smoothing. I get asked a lot, how many events should I smooth by? Where should I smooth? What should I smooth? And realistically, it sounds like a scapegoat answer, but the smoothing is appropriate to what you want to do. In this instance, we want to create some sort of semi-consistent pattern to differentiate the behaviors. So I want to smooth out my VEDBA until the wavelength goes up with one behavior, even higher for another, and then say down with another behavior. Or in other words, the value of VEDBA smooth changes with behavior. I think that will become more clear once I start to begin to build my equations. Let's smooth the VEDBA to try and change with the behavior. So I've got three behaviors here: grazing, walking, and standing or resting. Now, to smooth, we go 2D sliders. The first slider controls group by purpose. We go all the way down to VEDBA, Vespa, Oddba, and Animal G. The first one up here is acceleration smoothing for VEDBA and the other metrics. When looking at smoothing, when we talk about metrics or even a smoothing window, which can end up smoothing again on top of, we use a general rule of thumb of 1 to 2 seconds. That's why the default is set to 80, because the default sampling frequency is usually 40 hertz for acceleration. In this instance, I've used 20 hertz, so I'm actually going to need to halve that. I hope that made sense. So I'm just going to type in 40 and set. The smoothing is a running mean, and these behaviors are lasting seconds on top of seconds on top of seconds. So I will want to smooth for quite a long period to get that wavelength, the mint green or light green, to emulate the change in behavior. So I'm going to go for quite an extreme 160 events. It should set and update the visual. You can see if we up the amplitude, you can see how the wavelength is kind of trying to change with the behavior of the goat. This big one here is this distinct rise as the animal's clearly walking. Now I'm happy with that. Let's move to the behavior builder and begin to build an equation to successfully mark out this behavior. When you first open it up, it seems a bit overwhelming, but actually it's really simple, and there's a clear step-by-step process we can go through, and hopefully this video will give you a good idea of how you can build your own equations. So first we're going to select if. Once we've selected if, this will open up this next window, which we can then put in an equation or a number of parameters. I'm just going to use one because we're keeping it simple for now. So if, now I want VEDBA smoothed. So we scroll down. For this example, let's just pick out moving. So the moving, there's a clear rise in the VEDBA, but I want to know the threshold of that. So what we're going to do is we get up the display. By holding Control and Alt, I can go through the display and actually highlight a metric or channel that I'm interested in. In this instance, Vedba smoothed. Do a left click, and then it should remain highlighted in yellow. So I can scroll through the behaviors and get an idea of what my threshold or equation should be for that behavior. So if we're looking at moving, we don't want to pick out grazing. So we look at the numbers in grazing, they 0.14 goes all the way down to 0.07. Have highs of 0.16. Now we compare that to the moving. This kind of shows why it can be really useful to upload your behavioral data as bookmarks, because I can separate them really easily by the color of the bookmark. Moving on to walking, 0.19 it goes up to. It has lows, so I'm going to say if Vedba smoothed is more than 0.15, click enter to enter the value, close the bracket, then I'm going to assume that is moving, and we'll see how successful the equation is. We click next step, and it moves us on to this second step. Now we have to choose if we want to start a bookmark or stop a bookmark, but we're using simple marked events for this for now. So we're going to say mark events, and then we can evaluate the expression. So it's going to check the expression can be used within the data. So evaluate expression. Step 4 is we want to set the window that we want to test this equation. So I'm going to make this really short and sweet, as we're only testing it across a few minutes of the observed data. So we set that, and then we click go. Now my color is set to red for now. And as you can see, it picks out the majority of what I observed as moving, and a few false positives amongst the grazing. So let's try and make my rules a bit more strict to get rid of those false positives. We can do this by raising the threshold. Instead of building a new equation, we'll click Adjust Expression Parameters here. And we can scroll along using the slider till we find our value, which is 0.05. And let's just notch it up to 0.16. Set that. Close. And we can run the equation again. Now, I'm going to set a different marked event here. By setting a different marked event, it should highlight a different color. And we can compare the rules in a way. Select that as 4 and go. Right. So we've managed to get rid of these on the left. Still picking out some high Vedba values in the grazing here. But it still seems pretty strong, but we have lost a few events. When playing around with your equations, you might use a number of marked events, or you'll start to build up so many marked events that you'll end up filling the whole split with different colors. It's good to use this marked events control panel, where you can delete and search for the different marked events that you set for each equation. This instance, I'm just going to clear all marked events in the whole file to get rid of all the old ones. And then I'm just going to run this adjusted equation again. I've selected my marked event value to 4, which if you go to the marked events panel, you can understand the color scheme associated with a number. This time it's yellow. And it's picked out my behaviors as yellow. Next thing to do is store it. So it's moving. Let's call it version 1. Click store behavior, and then it's stored in the drop down above, and you can use it at any time. This allows us to also export our behaviors. And if we click export, it will write out them equations in a simple CSV file, which can then be later on imported. I'm now going to define a number of behaviors based on activity. I'm going to define grazing and resting. So let's rush through this. Okay, so I've successfully defined my 3 behaviors to an extent, and now I've stored them all so I can access them via the drop down, and I can then layer these behaviors on top of one another. So if I select resting using the drop down, select use, select my color, which I'm going to select as 1, and then if we click go, it will find all the resting. Do the same with grazing, but change the marked event. Go. And finally, moving. We now have this bar of marked events running through the bookmarks, and you can see where it's successful and where it's picking out false positives, or where it's even missing out potentially where the behavior has been undertaken, but the equation hasn't seen it as valid. This next example is wild dog data from a wild dog in ZSL London Zoo, and this species compared to the goat, as you can imagine, is much more dynamic, much more complex in its movement. I've already done some initial behavioral definitions, and I'm going to import them. So I go on the Behaviour Builder tab, click Import List, and then I'm going to select my behaviors I began to define, and it's going to ask me to clear my differential list. Once I've loaded it in, comes with its differentials, which we'll explain in detail later. At the moment, let's just hide those for now. Now I've imported my behaviors to kind of show you how these marked events equations can get much more complicated. So if I have a look at something really distinct like jump bite start, select that, click use. And if we just go through the equation step by step, I can translate it for you. If acceleration z smoothed is less than the y, so for example, the y value or the green values are higher than the blue or the z, and the z-besmoothed is more than 0.4, then mark events. So this implies a change in posture of the animal when it's quite active. So this is actually the dog on its hind legs biting into a carcass, and if we use this, it should pick out a number of different times that the dog was on its hind legs. So I've successfully marked out my jump bites, and now I'm going to use this to explain how to export this. So you can not only search the whole file for that behavior, but then you can also just export marked events. So if we go input output, file output save, and if we tick export marked events only, it will export just them marked events with the associated values that you wish to export. It's also worth noting that in the what to save and the extended, if you've got the expression builder marked events point ticked, it will give you a column with a value associated with that marked event. For example, the red is 1. So for every time, or for every event it picked out the equation as valid, it would mark it with a 1. And from that, I can begin to understand the duration of the behavior, how frequently the behavior happens, what time it happens, and also the activity-based energetics metrics associated with that behavior.